Let's practice naming some branched alkanes. So here we've looked at simple straight chain alkanes so far, and now we're looking at some of their structural isomers and how we name them when they have side chains like here and here. So first of all, we look at where our biggest hydrocarbon chain is. So we've got that through the middle here. And we've got 1, 2, 3, 4, 5, 6 carbons. So we know our backbone has 6, and we're going to call that a hexane. Now we can number those carbons, but we don't necessarily go left to right or right to left. We actually have to have a look at where these side chains are attached. So I can see here, this is a methyl group because it's got 1 carbon. So remembering meth for 1, eth for 2, prop 3, bute 4, pent 5, and so on. So if that had been this just on its own with hydrogen, that would be methane, but as a side chain, it's methyl. So we know we're going to have methyl in our name, and we've got another one here. So we've got 2 of them. We've got a methyl group here and a methyl group here. So it's going to be dimethyl. Now we have to put where they're positioned. So we start ordering our carbons from the end of the hydrocarbon chain that's closest to a side group. So here we'd be going 1, 2, 3, or from this side, 1, 2. So we start at this end. 1, 2, 3, 4, 5, 6. We can see that our methyl group here is attached to carbon number 2, and this methyl group is attached to carbon number 4. So we put 2, 4, and we put a comma in between them, and we just write them in order, smallest to largest, and a hyphen. And then this is all one word, 2,4-dimethylhexane. Let's try another one. Okay, so here we go. We'll look again. We'll identify our longest carbon-carbon chain here. So again, through the middle, we have 1, 2, 3, 4, 5, 6, 7. 7 carbons, so we need it's a heptane. So again, hept for 7, and ane meaning it's an alkane, so they're all single covalent bonds between the carbons. Then we look for our side chains. Here we have a methyl group, and here we have an ethyl group with an E because there are 2 carbons here, like ethane. Now we write these, we have to put the number of the carbon with the side chain, and we write them not necessarily in the order that they come off our carbon backbone here, but alphabetical order. So ethyl for 2 carbons, and our methyl for 1. Ethyl comes before methyl in the order. And then we look at where they are. Now this one, we can count 1, 2, 3 to our first side chain, or 1, 2, 3, 4. So we'll go in this direction to keep it the lowest number. So we can see that our ethyl group, which we're going to write first because of our alphabetical order, that's on carbon number 4. So we'll write 4 ethyl, and then we'll write 3 methyl. Sorry, it's a bit squashed in there. So this one is 4 ethyl 3 methyl heptane. So again, seeing the alphabetical order takes precedence over numeric order here. We'll try another one. So we need to identify our longest carbon chain. So you might go to start through the middle here again, and that would look like an ethyl chain, but actually we can turn corners with our carbon chain because of course these aren't really 90-degree angles, they're 109.5 because of our tetrahedral shape. So really our carbon here That's sort of our approximation of the shape. So it's actually really not 90 degrees. So these corners are kind of irrelevant because these bond angles are all the same. So our carbon chain, we would actually start here and go around the corner. And when we get to the end, this looks like it could be a methyl group here, but actually that can go around the corner as well. So here we have our main carbon chain. We have 1, 2, 3, 4, 5, 6, 7, 8. This is an octane. And then a side chain, we just have the 1. That's a methyl group. And counting, it's with shorter on this side to get to our side chain. 1, 2, 3. We can keep going, 4, but you don't need to. We can see that this methyl group is attached to carbon number 3. So it is 3 methyl octane. And that's that one. All right, what about if we are given, oh, these whiteboards are not great. Sorry, maybe I'll just flip it for now. What if we were given the name of one and we have to draw it? Let's say, how about 4, let's go ethyl, and maybe 2, 3, dimethyl. Let's go heptane again for that one. Okay, so we would start by, again, the same, going backwards of what we did before. I'd pick the backbone first. So our alkane chain here, heptane, is 7 carbons. I wouldn't add the hydrogens yet. Add your side groups and do your hydrogens last. So carbon number 4, now it doesn't matter, you're drawing it, so you can pick which end you want to go from. So in this case, I would probably just stick with going left to right. So on the position number 4, and you can do it above or below, it doesn't matter, we do our ethyl. So that means it's a 2 carbon chain. And then dimethyl means we've got 2, just tick off that, that's that one. And then dimethyl, we've got 2 methyl groups at positions 2 and 3. So we have a methyl group here. And we have one here. It's going to be a little bit squeezy. Very squeezy. And of course, there will be a little bit of repulsion here and twisting of our molecule if it was a real one. Okay, so we've put those in now, dimethyl. And then you just finish off putting in the hydrogens for the rest of the molecule. Now we get a bit fed up with doing that actually. Organic chemists drawing lots of hydrogens and carbons gets a bit repetitive. So sometimes we draw skeletal structures instead. So we could just draw that carbon here, go 2, 3, 4, 5, 6, 7. And then you go on your second one, you could have a methyl group, and your third one, a methyl group, and a fourth one, a dimethyl. So when we draw these structures, every corner is a carbon, and then the hydrogens are just implied. If nothing else is bonded to the carbons, we just assume that it's a hydrogen. So we can see this backbone, there's 1 carbon, 2, 3, 4, 5, 6, 7. This side chain, 1 carbon. This side chain, 1 carbon. This side chain, 2 carbons. So that's another way of drawing this, representing it. That's a lot quicker.